All right, 5.3, the sine law. Now, with the next two sections, we're going to be covering sine law and cosine law. Today, specifically, we're looking at sine law. Sine law is used when you don't have a right angle triangle. Now, not always are you given that right angle triangle that you're asked to figure out sides or angles. So a fast way to use that is by using sine law. Sine law is to be used with any oblique triangle where a triangle that does not contain a right angle. So given a triangle as such, we can use a law that's called sine law. Sine law is represented by the following. Sine A over A equals sine B over B equals sine C over C. What do we do with this? Well, folks, we can determine the value of any side or angle given that we have an angle and its opposite side. Now, sine law can be rewritten this way, but what's most important is we must be able to know an angle and its opposite side. Sine law is restricted in that way. So, looking at an example, you're asked to solve the triangle. So you're given a triangle MNP where angle little m is equal to 8 centimeters, angle M is equal to 29 degrees, and little n is equal to W is equal to 7 centimeters. So we have MWP and capital M, capital W, capital P. Because when we ask to solve a triangle, it means we need to know all the angles and all the sides, even the given ones. So we fill in the information we do know, and we determine how to calculate the missing information. Well, if you look carefully, by labeling inside the triangle and on the sides, we notice that we have an angle and its opposite side. Because of that, folks, we can actually determine all the other missing pieces of information. That is, sine of 29, sine M over M, sine W. Oh, that's a lot of information, folks, so let's go back a little bit. We'll just go backwards for a second. This is the sine law for this triangle here, but we don't need all of these pieces of information just yet. We do need the M over M because those two pieces we do know, and we need the next piece we're forced to find is angle W. The reason why is side W is opposite. We know what side W is. That means we can find angle W. So we're going to use sine M over M, which is sine 29 over 8, is equal to sine W over 7. And sine P over P we just don't know yet, so we're just going to cross that out for now. Alright, so knowing this, what we're going to do is cross multiply. We get 7 times sine 29 is equal to 8 sine W. Then we divide by 8. 7 sine 29 divided by 8 is equal to sine W. And because we're finding an angle, we use sine inverse to find the angle. And we find out that W is equal to 25.1006 degrees. Well, because we now know what angle W is, we can automatically find angle P using SATT. SATT says that angle P is equal to 180.29, minus 29 minus 25.1006. And we get 125.8994 degrees. So now we know what angle P is. Now, I know a lot of you are looking at, but angle P doesn't look that big. We did not draw this to scale, folks. So, next we need to find side P. Well, we will use sine law again, this time using sine M over M, which is what we were originally given, and sine P, which we just calculated, over little p. And we find out that when we cross multiply and divide, we find out that P is equal to 13.3669 centimeters. Now, let's look at the numbers and see if they match, meaning that is the smallest angle opposite the smallest side? and is the largest angle opposite the largest side? Well, if you look carefully, that information is correct. All right, folks, well, that's the end of the note. Have a numerical day. Take care.